the demand forecasting is important also in the supply chain because sorry, as we discussed in the first week, customer is one of the important part of the supply chain. Okay, without the customer, without the demand from customer, there is no use of conducting all those activity in the supply chains, because one of the goals is to satisfy the customer so that they can appreciate our product and service, and finally conduct some purchase on whatever product and service that we need, we give to them, right? However, sometimes we need to, in order to able to fulfill this customer demand, we need to have a proper planning. Okay, for example, to determine how many capacities that we need to provide to fulfill those demands, to, let's say, to determine how many stock that we need to have in our warehouse, okay, so that we don't miss the opportunity to fulfill those demands, and many things like allocate how many resources and things. So one of the first things that we need to have it well is to forecast those demand well. Okay. So later on, we will try to cover these several topics, which are the role of forecasting in supply chain, and then the characteristics of forecast, element of good forecast, and several forecasting techniques, especially the conventional one, and several forecasting tools. First is that this one, forecasting can be the basis for all planning decision in supply chain. Okay, take example. Oh, if I want to plan how many resources, how many human resources will I have in my department? So you need to plan. So you need to forecast. In order to determine how many resources, you need to check what will be the workload for each, well, how many tasks or assignment that you need to do in your department. Then you can determine how many resources were needed, right? Also in the production, for example, how many this type of component of this type of products I need to produce. You need to also forecast how many, how many those products were needed in the next period, for example. Then you produce those amount. Okay. It will be used in both push and pull process. Okay, I think you should already know what is push and pull process. Such as like in product scheduling, inventory, aggregate plannings, to also to do promotions, which one should promote more, which one should already enough with the promotions that we already have, something like that. Okay. Also including conducting equipment investment, budget planning, workforce planning, and so on. Okay. So formally, we can say that forecasting or forecast is a statement about future value of some things that we interest about. Okay. Forecasts are important because it is being used to make an informed decisions. Okay, several use of forecast in supply chain you can see here, like forecasting the level of inventory, use the forecast of demand to determine where the facility should be placed, to determine what type of product should be purchased, and to schedule the works, something like that. Okay. However, there are several features that is common to all forecasting techniques. First is that normally forecasting techniques would assume that there are causal system exists in the past that will persist in the future. Means that there are several patterns that we can study from the past data that will be repeats in the future. Okay. And then forecasting in the groups of items will be more accurate compared to the forecasting in the individuals of items. For example, if you are being asked to forecast, let's say, how many demand for a sedan car, for example, it will be much easier to forecast in the groups of items. For example, for all the sedan car, instead of you are being asked to, okay, what will be the forecast for a sedan car with a red color, for example? Okay, if you, the more specific you go for an items that you're forecasting, the less accuracy that you will have. That's the opposite of what are saying in the slides here. Okay, if you want to forecast, try to find a group of items that will be more accurate compared to the individual items. Okay. Another thing is that the longer the time periods that you have, the less accuracy for the forecast that is going to appears. Okay, so means that if you want to have a better forecast, the closer to the time frames that you are going to approach. For example, it is more difficult to forecast what will happen in the 5 years in from now compared to what happened in the next year. It is also more difficult to forecast what happened in a year compared to what will happen tomorrow in terms of demand, for example. For example, oh, if you want to forecast, okay, what will be the demand for a newspaper tomorrow? Okay, for this type of newspaper tomorrow, how many products is going to be purchased? Okay, it will be pretty much similar with what we have yesterday compared to if you are being asked, okay, what if you are going to forecast for a newspaper in the next year? Okay. So the forecasting horizons will also take place in the forecasting accuracy. Another thing is that forecasting is not perfect. There is always margin of error in forecasting. Okay, even though that for your trainings data, for example, oh, this forecast have 100% accuracy in their training. It is there is always chance that in practice, the longer you use those forecasting techniques, the more possibility that this will generate some error or forecasting error. Okay, because we are trying to forecast some random variation. Okay, some random variation means that there's always some residual of error, even those that all or the factor will already be counted for. Okay, so with those principles, we can have like in order to create a good forecast, you need to understand or know what is the element of a good forecast. A good forecast should be this one, have this characteristic. Timely, okay. It's not like, okay, I want it tomorrow. This forecast should be give me a result for tomorrow. But even though it's very accurate, but if not by tomorrow, then it's useless. That's what we call timely. It doesn't always be fast, means like, but it's right on time. And then the more accurate, the better. The more reliable, the better. Okay, reliable and accurate is different. Accurate is able to predict it well. Reliable, it means that with several tries, okay, if you do it for several cases, these forecasting techniques will have on average quite accurate number. Okay, It's not only one try. Okay, let's say one try, they get 100%. It means they are accurate. But after 100 trials, those forecasting accuracy will reduce. Means that it's not reliable. Okay, let's say it become 50%. It's not reliable. Okay, even though it's accurate at the first time. Okay, express it in the meaningful units, should be written, simple understand and easy to use, and then should be cost effective. That's why for today's discussion, I'm going to introduce you conventional forecasting techniques that can be easily used, simple and easily to understand, instead of start with the more sophisticated approach like machine learning and stuff. Okay. And in a conventional approach, we have two categories of forecasting. The first one is qualitative forecasting. It permits the inclusion of soft information such as human factors, decision, hunch. So it is more to a subjective type of forecasting. For example, sometimes it is, especially for a forecast with a long-term period, you are going to need some expert opinions in order to help it give a better forecasting result. That's where the qualitative forecasting comes into play. Okay, and for more like tactical and operational decisions in which you have a shorter forecasting horizons, quantitative forecasting technique will be more efficient because this technique will much rely on hard data. Let's say if you are going to forecast for the next month's demands, so you are trying to utilize the past month and the 2 or 3 months ago data. It's really dismiss the use of human factors and personal opinion. It's solely based on data. That's what we call a quantitative forecasting approach. Some were going to use mix between those two, and this type of approach is somewhat is more and more considered nowadays. Okay, here's are the examples of qualitative forecasting approach, like for example, using the executive opinions. Okay, let's say like you're conducting a small group of upper level managers, and then they are meet collectively and to develop share their opinions using these experts judgment. Okay. Or the sales force also can be used to determine the numbers of the forecast that you're going to use, and many other like customer survey and other approach. And here we will touch a little bit more on quantitative forecasting approach, in which I think it should be already discussed in the other type of IE or management class, like operation management and stuff. We often discuss this type of forecasting approach, like time series forecasting. Okay, time series forecasting is basically utilizing the data from the past, and you are using the averaging numbers approach. For example, if you are going to use the, let's say, moving average time series forecasting approach, you are going to use the past, let's say, three periods in the past, and then you use the average of it to forecast what will be in the future. For example, what will be the demand tomorrow? You will use the data from yesterday, 2 days ago, and 3 days ago. Let's say you use 3 periods, and you average this number, and you use it to forecast. Okay, this may be the number for the number of demand for tomorrow, something like that. Okay, so it involves identifying the patterns for the recent time series. Okay, and then it always based on the assumption that the estimated past the future value can be estimated from the past values. Okay. There are several data characteristics that you can understand first before using the time series approach. First is there is something called trend. Trend is a long-term upward or downward movement of data. Okay. For example, if your data in the time period is going up like this, it's an uptrend. If it is going down like this, it's a downtrend. Or if it is stable like this, it is stationary. Okay. And then there is seasonality. Seasonality is a short-term or a regular variations related to calendar or time of the day. For example, normally, let's say a holiday ticket demand, let's say for air flight, airplanes, tickets, will be higher in the holiday season. Yeah, it's a regular variations. For example, if you have the data is stable like this, and then in the holiday season, it is increased, spiking like this. And then it will go stable again like this. Okay. And there is also something called cycles. It's a wave-like variation lasting for more than 1 year. Okay. So seasonality, it's more like a calendar years. It's a yearly basis pattern. But cycle, it's like a wave-like. So you consider a multi-years and then see the patterns that look like seasonality. That's we call cycles. Okay. And then there is also irregular variations, which is variations due to unusual circumstances. Okay, that doesn't reflect the typical behavior. Okay. Another one is a random variation. Okay. Random variation is different with the irregular variation. Irregular variations reflects some things that is not typical. Okay. But random variation is some things that common for each uncertain data, but we can always say that okay, this may be some things that it's some things that always vary. For example, demands that even stable demands, let's say like this, maybe 5, 10, 5, 6, 7, 4, 3, and then again 5 again. So it's in this area, right? If the data is spiked somehow in the middle like this, we can assume this one is a irregular variation. However, if it is still in the upper and lower random variation of it, we can still call it regular variation, which is belong to, or the variation inside of this one, it's called a random variation. Okay. Next, okay, this now we talk about more specific type of forecasting techniques. First is the easiest one. It's called naive forecasting technique. Is just use a single previous value in the time series as the basis. Okay, so it's predicting what is happening yesterday will happen also tomorrow. So you use what is the demand for yesterday, you use it for the tomorrow's forecast. Okay. And then another one is the averaging techniques. Okay, sorry. Averaging techniques. Okay, we have several types: moving average, weighted moving average, and exponential smoothing. Okay, so basically it's used the averaging approach to help smooth the forecast number in the next period of forecast. So this one, time series forecasting means that the first one is the moving average, means that you are using the last n period, and here is the number of periods that you're going to use to forecast, to from the past to forecast the future. Okay, here we have future value FT, and then the forecast is that you average n number from the past. Let's say if you choose 3, so then n is 3, and then n actual number in the past 3. 3 here, if n is equal 3, so you use the last period, the second last period, and the third last period. Okay, and then you average it and you use it as the forecast value. Okay, and then if you add the weighted, for example, weighted means if you prefer some value, let's say, oh, you have the confidence in the last period compared to the previous period more, so you put weight here. For example, you put the weight here 0.5, and then the second last period will be 0.3, and then here will be 0.2. This weighted approach will sometimes work better to make it more reliable forecast. Okay, so this one called the weighted moving average. Okay, and then finally is the exponential smoothing. Okay, so you, instead of using a weighted, you use the actual value and the forecast value from the previous one, and you have a smoothing constant called alpha. So based on this, okay, another one is the linear regressions. I think I will explain this one next week, while providing you with an example on how to calculate it. Okay, so basically those are the forecasting techniques that we have. And then in order to choose which forecasting techniques will work better, we have a measurement called forecast accuracy. Okay, it is something that represents the allowance on that is made by the forecast error. Okay, the most likely we are going to find the forecasting techniques or approach that has the less forecast accuracy. Okay, and there are several measurements can be used, which is the formula is here. Some things called mean average deviations, mean average square of error, and mean average percentage of error. Okay, the formula is this one. I think it's easier to explain by example, but seems like the time is not quite enough today, so I guess like maybe we can try to do it together next week. I can try to provide you an Excel, and then we can do it together, and then I hope it can be the best way to help you understand about it. Okay. Okay, here's the, but before that, I expect you to try to watch these YouTube videos so that later on, if you try it in Excel, that you can already get used to it. Okay. And there is another software called POMQM. This is also recommended by an Operation Research books. The software is free, I guess, for the older version. So I think you can download it as well. And finally, this one is another tools that I want to introduce you, but maybe next week. Next week is better. Using K9. It's also connected with, if you want to later explore a data mining or data science approach without the ability to code. So this is a great tools that you can try. Okay. Maybe that's for today. Anyone would like to ask questions? Okay.